Okay, we're in section 4 of the notes now, and section 4 of the notes is this optional Sage code. Certainly someone says this is just a repeat of what you did in a prior section. It is, but now the Sage code pertains to what you're doing in section 4 of the notes. All right. I realize some should say, well, I don't want to use this particular software, and I'm not forcing you to use this software. What I'm saying is it's a good example of a computer algebra system, including, what's good about it and what's bad about it. And it's got warts. I mean, it's hard to use sometimes, but you're going to notice no matter what computer algebra system you're using, they all have warts. They're all not perfect. The more tools you have at your disposal, the better. So even if you go to NJIT and they're using MATLAB, you may start to realize that Sage is a lot more powerful than MATLAB, a lot more powerful. All right. What I mean by that, it's got tremendous variety of things you can do with it. Whereas MATLAB is kind of restricted. I'm not saying it's a bad product. It's a really good product that's used professionally, MATLAB. But Sage is huge. I mean, it's a huge, huge mathematical software package. All right. Now, granted, there's other better packages out there. What I'm going to say is, Mathematica is a really good package. It costs money. All right. Now, what's the low bar for you guys? The low bar is basically using what's known as a web-based application. Now, if you're running a Chromebook, this would probably be the most appropriate thing to do because Chromebooks, although you can install software on Chromebooks, it's difficult to do so. All right. It requires more technical savvy. But what do? You click on this. It's going to open up a Sage website for you. And just do the calc. Create a Sage worksheet. And again, if you're having trouble with that, although it's a low bar, if you do have trouble with that, please come by during my office hours and I'll be more than happy to walk you through that process. I don't like using web-based applications, and a couple of reasons why. One is typically I'm using somebody else's computer to do the computation, all right? And typically they're not going to let me have their computer to use whatever I want. And if I have a really big computation, they're just simply not going to allow it. My computer, though, is dedicated to me. I'm going to use my computer. Now, how do I do that? I run Sage on what's known as a terminal application. All right. So I'm going to type the code in for you. Reset. Hit the return button. Remember, if you're doing CoCalc, you have to hit shift return. I'm going to say X is a variable. It's a really good idea to define your variables in computer science. I got to be honest with you, though, in Sage, X is a default variable. You don't have to define it, but it's good. It's still good to be in the habit of defining your variables. Now I'm getting a little tired. I'm going to copy paste now. I want to point out there's a problem with copy paste. And the problem with copy paste sometimes is you're copying characters from one system to another, and there could be a problem. And I think some of you guys taking computer science realize when you copy paste code, i.e. you're stealing code, that sometimes it doesn't go well for you. All right, you shouldn't be stealing code anyway. But anyways, people do steal code all the time. Do they get caught doing it? Of course they do. So let's do this over here. F of, type that in for you. And it computes it. And what does it do? It takes the function f, which is x cubed minus 27 divided by x squared minus 9, and does computation. And so forth and so on. I could copy this line of code, type it in. I get this number over here, do this one over here. So I wonder what this is about. Well, if you've paid attention during lecture, paid attention during the examples that we've done, and have done the suggested assignments in the notes, this should seem like a really obvious question to you, what we're doing. And what are we doing? It looks like if you look at this thing, we're getting closer and closer to the number. Whoops, I didn't type that in right. I'm sorry. We're getting closer and closer to the x value of 3 from the right side of it. All right, if you look at the first value, it's 3.001, then it's 3.005. And then, I'm sorry, the first one was 3.002. The next one was 3.001. The next one was 3.005. And you know what? I could play this game all day long. For example, put another 0 here and a 5 there. Let's go for 1, even closer. I'm getting something over there. Now, what do I know about the sequence of these return values for f? 4.50, blah, 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 4.500, blah, 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 right? And then what do you get for the next one? 4.500, blah, blah, blah. Notice it. I'm making a prediction now that it looks like it's going to about 4.5. All right. Looks like it's going to 4.5. All right. Now I get to poke around the notes. I'm noticing they've got limit over here. And we'll talk about that later. I'm actually doing a limit of this problem. All right. I'm actually doing a limit. Let me see if I can do that for this problem over here. Limit f of x. I know this is tough. We're not saying you're there yet. X equals, well, it looks like I'm getting from 3, right? What's the direction? Well, the direction doesn't look like it's from the left. It looks like it's from the right. I'm thinking it's going to be 4.5. 9/2. What's 9/2? 4.5. So I'm looking at the code they're giving me, and I'm starting to realize, hey, Sage can do a limit. All right, let's do the next line of code, which is I'm going to clear this out now. And I'm going to do H equals of R. You know what? I want to copy paste and show you something. And I think some of you guys are in computer science are doing a lot of copy pasting with code. Like the teacher says, do a bubble sort. So what do? You go to the web, you search bubble sort, whatever language you're doing, whether it be Java, C, or Python, or whatever language you're using, doesn't really matter. You look at the code, you copy paste, you paste it into your assignment. Well, the people are smart enough to compile it, do that, and they get an error message. Let's see what happens. There's an error message. I want to tell you why there's an error message. When I copied it, the quote symbols are different. I'm going to retype that in and make sure what I'm doing over here. And I'm going to point it out. If you look at these quote symbols up here and these quote symbols down here, they're definitely different. That's an artifact of the typesetting system I'm using here. All right. Well, that went well. Let me type the next line of code in by doing a copy paste. And this is Python. G, it did that okay. Let's do G of 0.1. See, it did that okay. Let's do G of 0. Well, it looks like they got 2 zeros, 1, right? Well, I'm seeing that. You get the idea? Okay. Let's do G of 0. And we've done a lot of this in the homework, right? 0, 0, 0, 1. You get the idea. We can do this all day long. Get closer and closer to the 0. Right. So I wonder what that's going to give me. Well, I don't think I could predict that number. Other than the fact, I could say it's 1.94 something. I could say that. Right. Now, if you try G of 0, though, watch what happens. Big error comes up. What is it? Division by 0. You saw that last time. I'm going to clear. But when I clear, I'm not clearing any of the variables. I'm clearing the screen because it looks like nightmarish to me. All right. I want to copy paste this line of code over here, though. And again, the point of this thing, I want to point out, you are going to make substantial number of errors just by copy pasting. And I think the students that are taking computer science, you realize this by now. Another error. Someone says, I wonder what the error is. It's the quote symbols. I did it again. It says infinity. I want to go through this with you. And when someone says, why do you want to go through this with me? I want to make sure you know what we're doing. I'm going to define a function, f of x. Remember, we've already defined the variable x is being assigned this function here. And again, I'm trying to learn. And what I want to do now is I want to do f. I want to get close to 7 but from the left side of it. So what will we do? I'd probably do 6.9. Let's do that. It gives me that number. I want to get closer, f of 6.99. Now, I hope you realize we're to the left of 7. What do we get? 499. And I always say 3 is a charm. Let's try the next one. 6.999. I'm even getting closer to 7. I think I see the pattern. What's the pattern? It's definitely going off and getting bigger and bigger and bigger. And where's it going? It's going to infinity. This is the same exact thing that you did in Math 119 when you were doing asymptotic behavior. You would do both the left and the right. Let me do another one. I'm going to do from the right now. So f of what? What's to the right of 7? I'm going to say 7.1. Let's do that. I'll get this number over here. Let's do even closer to 7 from the right. And we'll do the limit, 0.01. That's 7 to the right now. All right, let's do another one. I always say 3 is a charm. 7.001. I'm going to say minus infinity. Well, you know what I'm going to do? I'm going to do this up here. And I'll type it in. Yeah, learning code. Right. I'm going to say it's minus infinity. Minus infinity. All right. Thanks for your attention. Again, this is optional. We're not trying to scare you with this. We're trying to get you introduced to using a computer algebra system. Not that you should be using this for homework or WebAssign or on exams. You should be learning this so when you transfer to another school, including NJIT or possibly another university, that you're familiar with the computer algebra system. Thank you.